In the next few days and lessons, we're going to be working with calculus on polar curves. And we've done a little bit of that so far, I suppose because we found the area inside of a polar curve. But what I'm really talking about here is using derivatives of polar curves and sort of interpreting them. And so the first thing that we might think about is this idea of dr d theta, right? Dr d theta is basically going to give us the rate of change of r with respect to theta. And in some sense, this should be the easiest of the derivatives to come up with, because we know that when we're working with polar, we pretty much always have r as some function of theta. We might have r equals 5 times the sine of theta. We know that would give us a circle of diameter 5. And so, by simply taking the derivative of this thing with respect to theta, by getting dr d theta equals 5 cosine theta, we can now use this and understand it as the rate of change of r with respect to theta. What we need to do next is we need to think about, so what does that mean? Like, what would it mean if that's positive? What would it mean if that's negative? What would it mean if it's 0? And that's what we're going to look at next. So here's where we're going to formally consider, what does it mean when dr d theta is positive or negative or 0? So I'd like you to, pause the video and think about this for a minute if you're willing, and just sort of think about what does dr d theta mean, what does it represent, and what would it mean, for instance, if it's positive. So if dr d theta is greater than 0, if it's positive, it means that r is increasing, which means it's becoming more positive. And so there are two different things that can happen. If r is already positive, if you have a positive radius and dr d theta is positive, it means that positive radius is actually becoming even more positive, which means the point is moving away from the origin, right? In a similar vein, if dr d theta is positive, in other words, the radius is increasing or becoming more positive, if your radius is already negative, then becoming positive means you're being drawn towards the origin. Like your radius is getting closer to being 0, which means you're getting closer to the origin. So that's effectively what happens when dr d theta is positive. I'd imagine you can now figure out what's going to happen when dr d theta is negative. So if you didn't do so the first time around, pause the video, sort of think through whether you know what's going to happen next. So it shouldn't be a whole lot of a surprise. When dr d theta is negative, it means that the radius, that r is decreasing, which means it's becoming more negative. So similar to what we dealt with before, if the radius is already positive and it's decreasing, it means the point is moving towards the origin, right? If dr d theta is negative and the radius is also negative, that means the point is moving away from the origin, because the negative radius is becoming even more negative. So that's what happens when dr d theta is negative. So the last thing to consider is, what would it mean if dr d theta was 0? And this should be a flashback to what we did in the first year calculus course, when we learned about dy dx being equal to 0. So pause and think about that one for a minute. Well, when dr d theta is 0, it means that the radius, the distance away from the origin, is not changing. And what that means is, we've seen this before, it means the distance from the point to the origin is a potential relative max or a min. If you're neither increasing your distance away or decreasing your distance away, it means that you're holding steady, and that's where you have a chance of being a max or a min. And the way that we determine if it's a maximum or minimum is the same that we did before, using something like the second derivative test or the first derivative test, where we look at whether the distance away from the origin is increasing or decreasing at a particular value. So now we'll move along and we'll look at an example of this. So let's see what we have. So here's this example, right? I have below the curve r equals 3 minus 5 sine theta, and I have the graph there. In part A, I'm first asking which of the colored points, I've got a red point, a purple point, a black point, and a blue point, which of those points is most likely to be the point corresponding to theta equals pi over 3? And this is just sort of a test of whether or not you guys know how to sort of read a graph and interpret where a point is. And the correct answer is that it basically has to be the black point, right? So the reason it has to be the black point is basically where the other points are. If we look at the red point is pointing in the direction of 0. It could be pi with a negative radius, but it's unlikely. The blue point is pointing in the direction of negative pi over 3. Now again, that could be 2 pi over 3 with a negative radius, but that's not pi over 3. This purple guy over here looks a lot more like pi over 6, and again, it could be 7 pi over 6, but it's definitely not pi over 3. Finally, you've got the black point here, right? This may feel like negative 2 pi over 3, But in reality, it's more than likely an angle of pi over 3 that simply has a negative radius. So we suspect that the black point is the point for pi over 3, and that it's happening because it's a negative radius. So with that in mind, and I hope you guys understand that bit about how we graph these things. We've talked about it, but I want to make sure you're remembering that. For part B, I want us to find an expression for dr d theta. Finding an expression for dr d theta should be very simple. We know that r is 3 minus 5 sine theta. All I need to do is take the derivative with respect to theta. That'll give me dr d theta is negative 5 cosine theta. So there's my answer for part B. Now part C is saying let's calculate the value of dr d theta at theta equals pi over 3. Alright, so let's just do that, right? For part C, I want dr d theta when theta is pi over 3, right? So if I evaluate that expression for pi over 3, I'm going to get negative 5 times the cosine of pi over 3. Cosine of pi over 3 is 1/2. So I'm getting this to be negative 5/2. Okay? So there's my dr d theta. We said previously that we're pretty sure that r is negative, but with the rest of part C, it says check your answer to part C, and what I mean by that is let's sort of check that answer by thinking about the motion of the point along the curve. So if we imagine that we started out here and that the point is going this way, at that point right there, does it seem like we're getting closer to the origin or further from the origin? Like again, imagine that your point started here at 0 and you're moving this way. As we go this way, when I'm right there, does it feel like I'm going to be getting further from the origin or closer to the origin? To me, like if I'm there and going this way, it feels like we're moving further from the origin. We could check that by going, well, I know that dr d theta is negative. What is r? Right? What if I were to take r, which was, my r was 3 minus 5 sine theta, and actually evaluate that using pi over 3, right? If I found out what r of pi over 3 was, I'd have 3 minus 5 times the square root of 3 over 2, and if we actually use a calculator for that, yep, it turns out that that is r of pi over 3. Turns out that this is negative 1.330. So we had a negative dr d theta and a negative r. That means that my point is getting further from the origin, which is what it looks like is happening in the graph. As we work through the problems that you guys have in the assignment tomorrow, I really want to make sure that you sort of get what's happening with these things, that we're using calculus to describe what's happening on the graphs, and that we're getting a chance to see that in the same way that we saw derivatives and original functions changing in the first year course. So hopefully that makes sense. If there's anything that was a little bit fuzzy, write down what your question is. Be ready to talk about it in class tomorrow. This is definitely strange stuff, so I'll be expecting questions.